Now let's talk about determining whether two variable expressions are equal or not, and what does that even mean. So consider the following question. We have two variable expressions. One variable expression is 3x plus 5, and the other variable expression is 8x. And the question is, are these two expressions equal? What does that mean? Right? Is it correct for us to say 3x plus 5x equals 8x? Is this true? Well, what does it mean that when two variable expressions are equal? What it means is that no matter what numbers we plug into these variables, what's on the left will always equal what's on the right. Now, what helps is that it's all the same variable, right? X, X, X. So one thing that you have to do, whatever number you plug into the first X, you have to plug in the same number into each other X. For example, if you let this X equal 2, then this X and this X must also be 2 because they are the same letter. And so let's evaluate these. Well, what happens when X equals 2? And I didn't have to pick 2, I just had to pick some number. Well, if X is 2, then we have 3x, which is 3 times 2, plus 5x, which is 5 times 2. And that equals 3 times 2 is 6, 5 times 2 is 10, and 10 plus 6 is 16. What about 8x? Well, 8 times 2, right? Remember, x equals 2. Well, 8 times 2 is 16. Looks like we have 16 on both sides. The left side equals the right side. Well, maybe it was a fluke. Maybe this only worked when x equaled 2. What if we pick a different number? What if we... So this first example was if x equals 2. Maybe let's try it if x equals 5. See if that gives a different result. Again, I just picked a random number. Well, 3x, which is 3 times 5, plus 5x, which is 5 times 5. 3 times 5 is 15. Plus 5 times 5 was 25. 15 plus 25 is 40. What if I look at my 8x here? Well, 8x is 8 times 5. 8 times 5 is also 40. Looks like they're equal again. You can try a few more numbers. You can pause the video, try a few more numbers just to make sure that no matter what number I plug into x, as long as I plug in the same number into each x, the left will equal the right. And so it's reasonable to assume that, yes, they are equal, right? The two expressions, the left expression, the 3x plus 5, and the right expression, 8x, are equal. Of course, you can't know for sure. You can't plug in every single number, but you can at least be reasonably certain once you plug in 2 or 3 or 4 that you're dealing with two equal expressions. And by the way, you will find that out later in the course, there are other ways of determining if certain expressions are equal in certain cases. But for now, we're going with the most straightforward primitive method. Let's take a look at another example. So here we want to see if the expression 6x plus 3 and the expression 9x are equal. Is it correct to say that 6x plus 3 equals 9x? Well, again, let's plug in some numbers. Well, what if, we'll pick an easy number, what if x equals 1? Well, if x equals 1, remember we had 6x plus 3 on one side and 9x on the other. If x equals 1, 6 times 1 plus 3. 6 times 1 is 6, plus 3 equals 9. Here we have 9x, 9 times 1, also 9. Huh, they are equal. What if we try a different number? Let's say if x equals 2. Well, if x equals 2, again, one expression is 6x plus 3. The other expression is 9x. Plugging in 2, 6x is now 6 times 2 plus 3. And 6 times 2 is 12 plus 3. 12 plus 3 is 15. If we look at 9x, 9 times 2 is 18. Uh-oh. We found the value of x where the left and the right aren't actually equal to each other. As long as we find one such case, we can now say that these expressions, they are not equal, right? They're not equal because they're not equal for all values of x. And by the way, if you try to plug in other numbers in for x, you'll find that the two expressions are also not equal. In this particular case, x equals 1 is really the only time when 6x plus 3 will equal 9x. So again, to reiterate, for two variable expressions to be equal to each other, you have to make sure that they're equal for all values of x. Otherwise, we say that the expressions are not equal. Okay, in the next video, we're going to explore literal expressions.